Hi grade 12s, we're starting this new section of financial maths. Today it's a paper 1 topic. It's only 15 marks in paper 1 and so it's a relatively small section, but it's quite fun in matric because we finally start to look at places where we would apply this in real life. So it's actually, I really enjoy this section in matric. It's also worth doing your best in simply because it's a relatively nice section where you can score easy marks, and so it's worth making sure that you know what's going on in financial maths. Okay, so we're going to do a series of topics, introduce a new concept every time, and so far we should know 4 formulas that should be on our formula sheet. So this topic is the revision from grade 11, and we're starting off with these 4 formulas. This year we're going to add 2 formulas to this list, but so far we should know that this formula is the formula for simple interest. Now just to remind us what simple interest is, simple interest is when interest is calculated on the original amount. Now, simple interest isn't really used very widely in the real world because why would you just charge interest or earn interest on an original amount? If your amount is changing all the time, your interest should change every time. So this is quite a rare form of interest, but it does pop up every now and again. So I've just written a note in there. Interest is calculated on the original amount. Now that means that even though the amount changes, your interest every month or every year will stay the same. So let's have a look at what these symbols stand for. You'll notice that they're the same 4 symbols in all equations. So this A actually stands for accrued amount. Now accrued amount, especially if you are doing accounting, you'll know that word. Accrued amount means the amount that you've gathered up. So basically the final amount in the future. Then you have P, which stands for principal amount, which by principal we mean original amount. So principal amount. Now you'll notice hopefully that I've actually spelt it incorrectly there because it is the principal amount as in the original amount. I stands for your interest rate, so this little I there stands for interest rate. Don't forget that all interest rates are given as a percentage. So all interest rates have to be written as over 100 because they're a percentage. And then probably the most misunderstood symbol here is the N, because everyone thinks it stands for number of years. But careful, we don't always get interest annually. So N actually stands for the number of times interest is added. So if interest is added monthly, then N will stand for the number of months. If interest is added quarterly, then N will stand for the number of quarters. Okay, so most of us will hopefully remember that. This second formula is the simple interest formula. The compound interest formula. And I'm hoping we remember that compound interest is when your interest is calculated on your current balance. So because your current balance is constantly changing because you're earning an interest, your interest will constantly change because it's always calculated on the current amount in your account or your current loan at that time. So I've just added a note in there that says interest is calculated on the current balance. Now the A, the P, the I, the N stand for the same thing, so you don't actually have to worry about that. Right, this third formula, this is depreciation. Now let's just remember what depreciation is. Now this isn't any depreciation, this is straight line depreciation. So I should have probably written that first. This is a straight line. Now depreciation is the loss in value of your assets. Now not all assets lose value. Generally equipment, computers, anything that can be used and therefore starts to become less efficient. So computers, equipment, cars, things like that, all of them lose values. So loss in value of assets is depreciation. Now not all assets lose value. Property and housing generally appreciates in that it generally increases in value. So depreciation can either be worked out on a straight line balance, which is basically the idea of simple depreciation, and it's called straight line because if you graphed what we call the book value, as in the worth of the asset, it generally goes down in a straight line. Now it goes down in a straight line because you're always losing the same amount of money every year because it's simple interest. In this case, simple depreciation. And our last formula, this is basically compound depreciation. but we call it depreciation. Either you can say on diminishing balance or reducing balance, because basically as your asset is worth less and less, you're always working out a percentage of that book value, and so your depreciation becomes less and less. And actually, if you plot the graph of a depreciation on reducing balance, it kind of looks like a hyperbola type of thing, because it's decreasing by a smaller and smaller amount every year because your asset is worth less and less every year. So hopefully those 4 formulas are fairly common to you and fairly you remember them all. We're just going to practice a couple examples and a couple of concepts which we should know from grade 11. Okay, so first example says a car depreciates on reducing balance, which means immediately you can turn to your formula sheet. Just be careful, any formula that's given to you, if you don't use the correct formula or you write it down incorrectly, they stop marking, because the idea is it's given to you, so you should be able to write it down properly. So you've got A, P, I, and N. I like to write myself a little list on the side. A car depreciates on reducing balance from 25,000, so that's your principal amount, to 15,000, so that's your accrued amount, your final amount, over 5 years. Determine the annual rate of depreciation. Now, you'll notice that your A always has to be less than P with depreciation, because it is losing value, and so you'll often come into a negative depreciation rate if you swap those around by mistake, and then you'll know you've made that mistake. So very quickly, this is 25,000. Oh, you see now I'm already making that mistake because I'm so used to A being bigger. So 15,000 equals 25,000. 1 minus I to the power of 5. I would then divide by 25,000 on both sides. I'd use my calculator, and I'd get 3 over 5. Then I need to get rid of an exponent of 5, so I would fifth root both sides. So I'd basically get the fifth root of 3 over 5 equals 1 minus I, so that power of 5 is gone now. Now, I don't actually show any of this working in an exam. I generally just work this out on my calculator. So your marks are for the first line, and then sometimes a mark for working, but if you don't show working, it doesn't really matter. So I worked out this fifth root on my calculator, and I get 0,90. So I get 0,902. Now, you've got to keep all those decimals, because ultimately in the end you're going to multiply by 100 because it's a percent. So definitely don't round off early. Now, what I do is I generally swap that to that side in my head, and I swap the I to this side. So I say 1 minus that rate, and then I times by 100. So I land up getting 9,71% depreciation per year. So that's how I do it. Again, I literally show my substitution, and then I generally skip straight to my answer. It is only a 2 or 3 mark question. Okay, now example 2 and 3 are about converting between interest rates. So let's just remind ourselves what type of interest rates you get. You get something called a nominal interest rate, and you get something called an effective interest rate. Now, an effective interest rate is where your interest rate, which is always generally quoted as per annum, which means per year, if it matches when it compounds, then that's called an effective interest rate. So it's called an effective interest rate simply because you effectively know exactly what you're getting. Whereas a nominal interest rate, you never kind of know what you're getting. So just to state that again, this is 13% per annum, and it's compounded annually. So those match, and so this is called an effective interest rate. A nominal interest rate is if I was to say to you, it's 13% per annum, but compounded monthly. So you're actually taking that 13% and you're dividing it up into 12 different parts. And because you're dividing up into 12 different parts, that's called a nominal interest rate. Now, there's 2 ways to convert between effective and nominal interest rates. I prefer the option of where I say, right, my 1 plus my interest rate for my effective, which is 13% compounded annually for 1 year. So I always compare 1 year of the effective, and it must be equal to 1 year of the nominal. Now, the nominal interest rate I don't know, but I know it's compounded monthly, so I know I must divide into 12 months, and I know you'll get interest 12 times in 1 year. So you always compare 1 year to 1 year. Now, the idea of making these equal is that you're trying to convert this to an equivalent interest rate. So these interest rates must be the same. So I literally then just use my calculator. I get 1,13 on this side. Now I need to get rid of the exponent of 12. Now we've discussed this idea before, so I 12th rooted the one side. So I 12th rooted this side, and I got 1,0102, blah, 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 which is 1 plus I divided by 12. I minus 1, I multiplied by 12, and then I multiplied by 100, and I got 12,28%. Now again, you don't have to show too much working. As long as you've got your first line, the working kind of can take care of itself on the calculator. Now let's just quickly pause. Does this make sense? Well, you're getting a value that's less than 13%. Now that absolutely makes sense, because an effective interest rate means you only get 13% once. A nominal interest rate means you're going to take this 12% and you're going to divide it up into 12 equal parts, and then every month you're going to get interest on the interest. And so you automatically generate more money when you do compounding more often. Okay, let's have a look at the other option. The other option would be to take 100 Rand and to work out what would 100 Rand be worth after 1 year. So you put your money in at 13% compounded annually for 1 year, and you get 113 Rand. Now your option would be to say, right, how do I get out 113 Rand from 100 Rand if I don't use 13%, but I use some interest rate compounded monthly for 1 year, which is 12 months. And then what I would do is I would divide by 100 on both sides. So I get 1,13 equals 1 plus I divided by 12 to the power of 12. And you'll notice I'm now straight back there. So you do actually get down to exactly the same maths. Now that brown option that I've done is what people generally find easiest, is to put in 100 Rand with what you're given and then try and work backwards from that final amount. So just to remind you, I would take the 12th root to get rid of that, and I'll get 1,0102, blah, blah, blah. Don't forget not to round off too early. Then I would minus 1 from both sides, so I'd actually get 0,0102, blah, blah, blah. And then I would multiply by 12 and multiply by 100 to get my percentage. Great, so let's try another conversion. This question says convert 11% compounded quarterly. So I have got a nominal interest rate because it says per annum, but it's compounded quarterly, so they don't match. And they want you to convert this to an effective annual interest rate. Okay, well, let me try my version first that I always use. I say, right, I have 11% compounded quarterly for 1 year, which would be 4 quarters. Now I want that to be equal to an effective interest rate compounded once in a year for 1 year. So if I work out my bracket, let me see what I get. I get 1,1146 equals 1 plus I, because those exponents of 1 doesn't really matter. So I minus 1, and then I times by 100, and I get 11,46%, which makes sense because it has to be bigger than 11%, because an effective interest rate, you'll only get interest once. And so it has to make up for the fact that you're not getting interest on interest. The other version would be to say, right, if I put in 100 Rand and I got interest at 11% divided into 4 parts for 1 year, so that's 4 quarters, how much money would I get? And I would get 111 Rand and 46 cents. Okay, so how do I take 111 Rand and 46 cents, and how do I get that from 100 Rand if I was getting interest for 1 year? So I divide by 100, and I'd get 1,1146 equals 1 plus I, and you'll notice I'm right back at the same place. So I'd minus 1, I'd times by 100, and I get 11,46%. So it doesn't actually matter which way makes more sense to you. Okay, so rather just pick a way that you understand and then stick to that. Okay, so that's converting, which is kind of the big thing we learned in grade 11. The other thing we learned in grade 11 is the idea of timelines. So we're just going to practice one timeline. This timeline says you deposit 2,000 Rand into a savings account. So at time period 0, you deposit 2,000 Rand. 3 years later, so at time period 3, you add another 3,000 Rand. And 5 years after that, so always just be careful about 5 years after the beginning or 5 years after that, you withdraw 1,000 Rand. It says interest is calculated at 10% monthly for the first 4 years. So that is 10% monthly, so that's 10% divided by 12. You can actually write, I just am in the habit of writing decimals. You're welcome to write 10% because you do have a percent button on your calculator. And then it says it's 8% thereafter. So thereafter to wherever I'm interested in going, it's now 8%, which, just be careful, is not 0.8, it's 0.08, and that's compounded quarterly. How much money do I have after 9 years? So it's actually T9 that I'm interested in. Okay, now I'm hoping that you learned in grade 11 that the most effective way to do this is to take each amount and treat it separately. So what would 2,000 Rand be worth if it was an investment and I invested it for all of this time? So I would take 2,000 Rand and I would add interest at 10% compounded monthly and for 4 years, and then the interest rate changes. So that's 48 months. Now the interest rate changes, and the interest rate changes to 8% compounded quarterly, and that's now 5 years, because the difference between 4 and 9 is 5, and in 5 years there's 20 quarters. Okay, now what I'm going to do is I'm going to say, well, let's pretend I just had 3,000 on its own. What is 3,000 Rand worth all the way at the end? So 3,000 Rand will be invested at 10% compounded monthly, but only for 1 year, because from 3 to 4 is only 1 year. So that's 12 months. Then it's 8% compounded quarterly for the full 5 years. So that's 20. And then finally, what I've got is I've got my 1,000 Rand, and I need to move that all the way to the end. My 1,000 Rand didn't get any of the 10% because it wasn't withdrawn yet. So it's only the 8% compounded quarterly, and that's only 1 year between the 8th year and the 9th year. So that's only 4 quarters. Now this question told me that I added in 3,000 Rand and I subtracted my 1,000 Rand. So if I put that all into my calculator, I will get the answer of 6,931 Rand and 10 cents. Now, does that make sense? Well, 2,000 plus 3,000 is about 5,000, and take away 1,000 is 4,000. But each of these had a whole bunch of interest, so 6,900 sounds fairly possible. Now, the most important thing with timelines is don't ever forget, you can only ever add money together if you know what that money's worth at the same time. So you can never add the 2,000 and the 3,000 together, because that's 2,000 Rand in 3 years' time is not worth 2,000 Rand. It's gain interest. So that's why we move them all to the same place. And here I chose the end. I could have chosen anywhere, but it made sense to move them all to the end and then add and subtract them. Right, so that's pretty much revision of grade 11. Our 4 formulas, can we convert between interest rates? Can we use those formulas, and can we do a timeline?